Hello students. Today we are continuing with the linear equation in two variable. This is your part 2. In the previous part we have discussed about how to solve two pairs of linear equation which has two variables in it. And we have also discussed conditions called consistent, and then there was inconsistent, then another third one called dependent. We have discussed their conditions. What are the conditions for two pair of equations to be consistent, inconsistent, or dependent? And we have also discussed how their graphs will look like, right? Okay, now I'm taking up straight from question number 3 from your exercise 6.1. So the question is saying you have to solve the pair of equations graphically. We're given here two equations, x plus 2y is equal to 8, and the other is 3x minus y is equal to 3. So before we go on to the solution of this, let me remind you how to draw the graph of a particular equation, right? So first of all, we need to draw a table. A table will look like this: x, y. You have to put the values of x and the corresponding values of y. You need to take at least 2 points, because a graph is a line. The graph that a linear equation in two variable it will produce is a straight line. So in order to obtain a straight line, you need 2 points. So what you obtain on the point, what you obtain on the tables, let's say you obtain a table like this. This is imaginary, okay. This is not related to these two equations right here. If we have something like this, then this one, these two, the values above, the values of x here, there will be the x coordinates. And the value of y here, there will be the y coordinates. If I combine two values of x and y, one value of x and the corresponding value of y, let's say I combine 1 and 4, then I will write 1, 4. This is 1 point. And from here, if you look, we have 2, 5. 2 and 5 are the corresponding values. So we have got 2, 5. This is another point. So 1, 4, and 2, 5, you just have to plot in the graph paper with respect to the two axes given there. And then you have to join the 2 points. That way you will get a line of this corresponding table right here. And I've also reminded you all about how to put up this point 1, 4. This one is this one is the x coordinate. So you have to go 1 in the x direction. And then if this is positive, then you have to go up. There is 4, so you have to go 4 points up. If there is a minus 4 right here, then you have to go 4 points down. Okay, let me take up 3 questions from your question number 3 of exercise 6.1. I'm going to take up Roman number 8, Roman number 10, and Roman number 12, because they differ. They produce different forms of graph. Okay, for now, let's focus on this. First of all, in order to solve the two pairs of equations graphically, first you need to draw the table for the first equation and the second equation. Okay, let's proceed. Let's take up this equation first. X plus twice y is equal to 8. So let's write the proper solution. X plus twice y is equal to 8. You can find out any of the variables you like. Find out x or y. It's up to you, your choice. But in this one, it's easier to find out the value of x, which will be, take the 2y to the other side, we will obtain 8 minus twice y. Now let's draw up the table. Okay, let me write table number 1. Table number 1, we have got x here, y here. Okay, here on this right hand side, we have got the value of y. If I put the value of y, then you can do the calculation, and then we will obtain the value of x, right? So let me put up y is equal to 4. Okay, so if y is equal to 4, what is the value of x? 8 minus 2 into 4, which we are going to obtain as 8 minus 8, which is 0. So when the value of y is 4, the value of x is how much? 0. Let's put here. When the value of y is 4, the value of x is 0. Take a one more point. Just put in the value of y. Think of any value, okay? But remember this, we don't want fractional points there, because plotting fractional points in a graph is will be slightly difficult, okay? If given, if the decimal digits after the point, if they are very small, it will be difficult to plot in the graph itself. So better do not try to obtain any fractional value of x and y. Better to obtain whole numbers or integers. So let me take up another value of y. Let me take up y is equal to 3. How about now? We will get x is equal to 8 minus 2 into 3, which will be 8 minus 6, which is 2. So when the value of y is 3, the value of x is how much? 2. Okay, I'm putting it here. The value of y is 3 and the value of x is 2. Okay, you can take a one more point. Okay, you can take a one more point here. It's up to you. But we have got 2 points, which is enough to draw a graph. So what are the values of x and y? X is 0, 2, y is 4, 3. 4 is corresponding to 0, 3 is corresponding to 2. What are the points that we obtain then in order to plot in the graph paper? We have got 0 and 4 here. We will put them as 0, 4. What about the other? 2 and 3. 3 is corresponding to 2. So we will put 2, 3. Okay. And remember this, you cannot put 3 first and 2 later. Why? The points you have to put like this. The value of x first, the value of y later. So from this, if you take 3, 2, it will represent a different point than 2, 3. Okay. So you have to put the value of x first, the value of y later. So these are the 2 points we have obtained from this equation itself in order to draw the graph, right? So let's just write the points are 0, 4, and 2, 3. Now let's come to the graph paper. Let's draw x and y axis first. You focus on the graph paper right here. So this is a graph paper that you have to obtain separately in your exams. So let me put up x-axis and y-axis. So let's draw here. This is the y-axis. And let me draw x-axis with a different color. Okay, so we have got x-axis. This is the origin, the middle one. The middle is the origin, the point where the two axes cut itself. You have to write x here, x prime here. This side represent the negative x-axis. This side represent the positive x-axis. This side represents the positive y-axis. This side represents the negative y-axis. So you have to put y here, y prime here. The y prime is the side for the negative values. Okay, now let's plot the value of 0, 4, and 2, 3. Okay, and then remember how to mark it. 0, 4 are very small values. So you can take like this. This is 1 square, right? You can take up 2 squares. You can take up 3 squares. It's up to you. But for me, let me take up 2 squares. 2 squares in order to plot our one value. So let's put 1 here, 2 here, 3 here, 4 here, 5 here, and 6 here. Okay, let's mark on the y-axis also. Same thing. 1, 2, 3, 4. Let's put up some negative values. -1, -2. That must be enough. Okay, so what are the points that we need to plot? We need to plot 0, 4, and 2, 3. Where is 0, 4? 0 means on the x-axis, you don't move anywhere. X-axis, you have to stay in the origin 0 value. Y-axis, you have to go up because the value of y coordinate is positive. 0, 4, from the 0 point, you have to go up. Up how much? 4 points. From here, you go 4 points. 1, 2, 3, 4. Okay, so here is your point, 0, 4. So this is your point, 0, 4. What's the other point? The other point is 2, 3. 2, 3 means along the x direction, you have to go 2 points. Go 2 points like this. Then on the y-axis, you have to go 3 points. So go 3 points up. 1, 2, 3. So 2 points on the x-axis, 3 points on the y-axis. Here it is, right? So here is your point. What is this point now? This point is 2, 3. Okay. When you use a very sharp pointed pencil, when you mark it with your pencil tip, it might not be seen on the graph paper itself. Okay, the examiner might be confused where the point is actually. So as a tip, better circle the points that you have plotted. This is the point. This is the point. Okay, you have to encircle it so that there is better visibility for the examiner for your paper. Okay, now since we have the 2 points, let's just join them. Let's join the 2 points. Let me draw it with a red line. Okay, here it is. Okay, let me draw it a little more straight. Okay. Here is your point. Here is your graph. What is this the graph of? Because we have prepared a table and the points from x plus 2y is equal to 8. This is the graph of what? X plus 2y is equal to 8. Okay. Now, since we have already drawn the graph of x plus 2y is equal to 8, let's proceed to the next equation. Next equation is what? 3x minus y is equal to 3. Okay, so let's make up a new table and new points for this next equation. So we have got 3x minus y is equal to 3. Let's find out y. Bring the y to the other side, take the 3 to the left hand side. We will have 3x minus 3 is equal to y. Exchange the sides, so we have got y is equal to 3x minus 3. Okay, now let's put up the table for this particular equation also. I'm going to write this as table number 2. Let's erase the old values. Okay, 0 here, 2 here, 4, 3. Okay, now let's make up 2 more points for this 3x minus y is equal to 3 also in order to draw the graph. So let's put the value of x as 1 first. X is equal to 1. What is the value of y now? Y is 3 into 1 minus 3. So we are going to get 3 minus 3, which is 0. So when the value of x is 1, the value of y is 0. So we put x as 1, the value of y as 0. Let's take a one more point. Let's take a x is equal to 2. Then what is the value of y now? Y is equal to 3 into 2 minus 3. So we have got 6 minus 3, which will be 3. When x is equal to 2, y is equal to 3. Let's put it here. X is 2, y is 3. What are the points then? This point, 1, 0, right? What about this? This is 2, 3. So the points are what now? 1, 0 and 2, 3. Okay, so for this particular equation, we have got these 2 points right here. Let's plot them on the graph paper. Okay, let's focusing on the graph paper right here. Where is 1, 0? On the x-axis, you go 1 point, and then you don't go absolutely anywhere along the y-axis. You just stop here. Don't go up or down because there is 0 for the y-axis. Go 1 point along the x-axis and then stop. Don't go up or down. So here is your point. This is 1, 0. So I'm writing 1, 0. Here is the point. Okay, and then remember you have to encircle it. Okay, for better visibility of your examiner. What's the other point? The other point is 2, 3. It's already plotted, right? You don't need to repeat it. So in order to draw the graph for this 3x minus y is equal to 3, you just need to join these 2 points, this point and this point. Join them. Let me draw with the different color here. Let's draw yellow. So sorry, it's not actually touching the 2 points. Okay. So what now? This yellow is the graph of 3x minus y is equal to 3. Okay, if we want to find out the solution of these two equations, we are concerned about the point which is in both graphs. We have got 1, 0 and 2, 3 for 3x minus y is equal to 3. For x plus 2y is equal to 8, we have got 0, 4 and 2, 3. Which one is in both the graphs, both the lines? 2, 3 is in both the lines, right? That means the 2, 3, it satisfies this equation as well as the second equation. That means this is the solution. If we take 2, 3, the value of x is 2 and y is 3, it will satisfy both the equation. So the value of x and y that satisfy both the equation is the solution of the two given equations. All right. So once the points and the tables for a particular equation is done, let me rub this off. Coming to the solution, where do the graphs intersect? We have to say the graphs, they intersect at where? 2, 3. Therefore, what is the solution? The solution is 2, 3. What is the meaning of 2, 3? The value of x should be 2, y is 3. That is, x is equal to 2, y is equal to 3. Try putting in this value, okay? Try putting in this value in first equation and second equation also. Look here, if I put 2 here, 2 plus 2 into, instead of y, if I put 3, what do we get? We get 2 plus 6, which is equal to 8. That is equal to the right hand side, right? And what about here? If I put 3 into, instead of x, we put 2. And instead of y, we put 3. We get 6 minus 3, which is 3, which is equal to the right hand side. This value of x and y, it satisfies both equations. So this is the solution of both the equation. Okay, where is the solution? We obtain the solution from the point where the two graphs intersect. Get it? Okay. Now let's move on to another two pairs of equation. What is this now? We have got x by 2 plus y by 5 is equal to 1. The other one is 5x plus 2y is equal to 10. Okay, let's proceed to the solution. You just have to put the table for this first equation and then take up 2 points. And we join the 2 points, we will obtain the graph for this. Same thing you do for this one. So if I take up the first equation, it will be x by 2 plus y by 5 is equal to 1. It is always easier if we put the equation in this form. Here we have got two values, two constants as denominator, right? We don't want this. So better if we add them, by taking LCMs of the denominator. So we get 2 5s are 10, cross multiply. We have got 5x plus twice y. 2 and 5 is multiply, we have got 10. X and 5 is 5x. 2 and y is twice y is equal to 1. Then do a cross multiplication between the right hand side and left hand side. 10 and 1 is 10. 5x plus 2y, here is a 1 denominator. If you multiply 5x plus 2y and 1, we have got how much? 5x plus 2y is equal to 10 into 1 is 10. Okay, before we proceed to the table for this equation, look at the other equation. We obtain this from what? First equation. But look, it is the same as the second equation, right? This equation is same as the second equation. That means we are solving two equations which are same. What do we call them? The other equation is 5x plus 2y is equal to 10. If I divide the coefficients of x, y, and then the constant terms, what will it be? 5 by 5, 2 by 2, 10 by 10. This one will produce 1, this one will produce 1, this one will produce 1. So this satisfies the condition of a1 by a2, b1 by b2 equal to c1 by c2. What do we call these conditions? We call this as dependent, right? Dependent means if I draw the graph of this equation and this equation, we are not going to get two separate lines. We're going to get the same line. Okay, so that means you can put up the same table for this equation and this equation. Get it? Okay, now let's put up the table for this. So table 1, x, y. So 5x plus 2y is equal to 10. Then we find out the value of y. Twice y is equal to 10 minus 5x. If I find out y, 2 will go to the other side. It will become division, right? So here, in this case, what I said before, do not try to obtain fractional numbers, okay? Fractional values of y or x, we don't want it because it will be difficult for you to plot it in the graph. 10 minus 5x by 2, since there is a 2 here below, better you take values of x so that after subtraction with 10, you will obtain values which are divisible by 2. For example, let's say I take x is equal to 1. What will happen then to this value, whole value of y? Y is equal to 10 minus 5 into 1 divided by 2. 10 minus 5 divided by 2, what do we get then? 5 by 2. This is a fraction, right? We don't want to obtain this. So better do not take x is equal to 1 in your table. This is correct. Okay, when x is 1, y is 5 by 2, this is correct. This is the solution. But we don't want this 1 and 5 by 2 values in order to draw, in order to plot it in a graph. We don't want fractional numbers. Okay, so if I take x is equal to, let's say 0, what will the value of y be? Y is equal to 10 minus 5 into 0 divided by 2. So we have got 10 by 2, right? 5 into 0 is 0. So 10 minus 0 is 10. 10 by 2, how much is it? This is equal to 5. What if I take x is equal to 2? Y is 10 minus 5 into 2 divided by 2. So we get 10 minus 5 into 2 is 10 minus 10. So we get 0, right? Better put it as 0. So we get 0. Okay, you put these two values in the table. When x is 0, how much is the value of y? It's 5. And when x is equal to 2, the value of y is 0. What are the points? What are the points now? The points are, we have got 0 and 5. Put them together, we are going to get 0, 5. What about the other one? And 2, 0. Let's plot them. Okay, first let's draw the axis. This is the y. Let's draw the y x-axis also. Okay. So you have to mark the origin, y-axis, x-axis, positive, negative, all of them first. Okay, before proceeding, we have got y here, y prime here, x here, x prime. Now, what are the values of x? It's 0 into very small, right? What about y? Y is 5, 0. So let me take the value of, let's plot the value of y. This is 1, this is 2, this is 3, this is 4, 5. Let's take 2 more, okay, 7. What about the value of x? 1 here, 2 here, 3 here, 4 here, 5. Okay, you can take more if you want, okay? No issue. Now, what are the points that we need to plot? It's 0, 5, and 2, 0. 0, 5 is where from 0 you have to go up 5 points. Here it is, right? Okay, let me mark it with green, and then you encircle it. So what is this? This is 0, 5. What about the other? The other is 2, 0. Go 2 points on the x-axis. Do not go up or down because along the y direction you don't go anywhere. So this point is 2, 0. So this is 2, 0. Let's encircle it also. Okay, now draw the graph, the line. You just have to join the two. So here I'm joining like this. Sorry. Okay, let it. So we have got this graph here. This is for which equation? We take the first equation, right? We take the first equation, x by 2 plus y by 5 is equal to 1. So this graph will be x by 2 plus y by 5 is equal to 1. But we change this into what? 5x plus 2y is equal to 0 for convenience purposes. And if I take up the next one, if I take up the next one, 5x plus 2y is equal to 10, right? So I can start from here. 5x plus 2y is equal to 10 because it is the same as the previous one. Just need a little bit of a rearrangement. You will get the same. You can put the same value and then same table. So this can be table 2. So for the second equation, I can just rub this off. And then I can just replace the table 1 with the words table 2. You can just put it as table 2. So you are going to get the same point. You are going to get 0, 5, and 2, 0 also. You can take up other values of x and y, but you are going to get the same line. Okay, if I take up a different value other than 0 and 2. Okay, let's take different value of x other than 0 and 2. So here, let me just take other values of x and y other than 0 and 2. Okay, let's not put 0. Okay, so the value of y is going to be the same because it's exactly the same equation. 5x plus twice y is equal to 10. Now, if I put the value of x as minus 2. So how much then? The value of y will be? Y will be 10 minus 5 into minus 2 divided by 2. So we have got minus 5 into minus 2 is plus 10, right? The minus and minus will multiply. 5 and 2 will multiply. We have got 10 here. 10 plus 10 is 20. 20 divided by 2, so we have got 10. When x is minus 2, x is a negative value of minus 2. The value of y that we are obtaining is 10. Let's take up another. If the value of x is 20, suppose. No, the value of x is 4, suppose. X is equal to 4. What's the value of y now? The value of y will be 10 minus 5 into 4 divided by 2. This will be 10 minus 5 into 4 is 20, right? So 10 minus 20, we will get minus 10. So what we are going to get is minus 10 divided by 2, which is minus 5. Let's put on these two values in the table here, minus 2 and 10. So just write here, minus 2 and 10, 4 and minus 5. What are the points now? You have to replace the points. It's no longer 0, 5 and 2, 0. It's minus 2, 10. What's the other one? The other one is 4, comma, minus 5. Okay, plot them. Where are they? 4 comma minus 5, since the y-axis has a negative value, the y value, y coordinate has a negative value, you have to put negative values in the y-axis also. Here, we forgot it here. Just this is minus 1, minus 2, minus 3, minus 4, minus 5. Okay, let's put some negative value in the x-axis also. Let's just make the y-axis a little bit longer. So here, here is minus 1 and here is minus 2. So what are the values that we need to plot? We need to plot is minus 2, 10. 10 is not in the y-axis. So 10 you have to put up 7, 8, 9, 10. So let's make the y-axis a little bit longer in the positive direction also. So we have got 8 here, 9 here, and 10. So what are the points that we need to plot? We need to plot minus 2 comma 10. Minus 2 comma 10 is along the x-axis you have to go negative twice, -2, and then along the y-axis you have to go 10 points here, like this. Here it is. Here is your point. Here is your point, minus twice 10. So here this point is what now? -2 comma 10. Encircle it. What about the other one? The other one is what? 4 minus 5. 4 minus 5, where is it? 4 minus 5. 4 in the negative direction, go 5 points down here. So we are going to get, here is your point, 4 comma. Okay, let's encircle it also. What are the points that we need to join in order to obtain the graph for 5x plus twice y is equal to 10? These two, right? If I join -2, 10, and 4 minus 5, we are going to get the same line as the previous one. It's one above the other, right? So we are going to get the same line. Same line. So if I draw it with the yellow, it's the same line. Okay, the graph for x by 2 plus y by 5 equal to 1, 5x plus twice y is equal to 10. We are getting the same line, even if we take different values of the points. So what this means is that these two equation, when we draw the graph of them, we obtain what now? Two lines which are coincident. Coincident means one sits on the top of the other. That means the two equations, every point that satisfy the two equations. In case of -2, 10, 0, 5, 2, 0, 4 minus 5. If I put it here or here, if I put -2, 10, x is -2, y is 10. If I put it in the first equation or a second equation, it's going to satisfy both of them. You can check it, okay? If I put 0, 5, 0, 5 will satisfy this equation and this equation. 2, 0, it will satisfy this equation and this equation. Same thing with 4 minus 5. Okay, whatever point that comes in the line here, it will satisfy both equations. Look in the previous part. Look in the previous question. There is only one point, the point where the two lines intersect, that satisfy both equations. The others, if I take 0, 4, 0, 4 is going to satisfy the first one only, not the second one. If you put 3 into 0 minus 4, we will get 0 minus 4, which is -4. You don't get 3, right? It doesn't satisfy the second equation. But if I put 2, 3, 2, 3, it satisfies these two. So 2, 3 is the solution. But in this case, in the case of the two equations right here, every point on this line, whether it is -2, 10, 0, 5, 2, 0, 4 minus 5, all of them will satisfy these two equations. So when you are asked about the solution of two dependent equations, what you are going to answer is, you will say there are infinitely many solutions for the two equations. So here, the final answer that you are going to give is, you have to say here, the graphs of the two equations are dependent. That is, there are infinitely many solutions. You don't need to put any particular point, okay? You just say infinitely many solutions. So this condition, what do we call it? We call it as dependency or dependent. One thing that we missed out here, one thing that is missing from the graph is something called scale. Okay, let me point out the difference between this graph and the graph of the previous one. Previous one, look closely. This is a large square. This is a large square. Zoom it in. What do you see? Inside the large square, there is 100 another square. Okay. If I draw this line, it is divided into 10 more. Okay. So small, small, small. There are 10 small square that make up this portion. Here, when we take 10, when we take one here, we take from here to here. We take up two squares, right? Two big squares, right? So this is a big square. In order to put 1 point, we take up two big squares. One big square consists of 10 small squares. Get it? If I take this portion only, there is 10 square, very small, 10 squares. Since in order to put one here to here, I take up two large square. How many small squares will there be in between here and here? There will be 20 of them, right? But here, look at the graph of this one. In order to put 1 point here up to here, this distance only, I took up only one large square. I take up only one large square. How much does the large square consist of? It consists of 10 small squares. Okay. So in order to indicate the difference, you have to mention something here, something on the top right hand corner of this portion. You have to mention here. The word should be like this. It should be as scale. The scale will go for x-axis and y-axis as well. What about the x-axis? In the x-axis, this 1 unit is equal to how much? 10 small squares. So you have to mention here 10. I'm going to write it bigger. 10 small squares is 1 unit. Okay, y-axis also same thing. If you look it in the y-axis here, you focus on this portion right here. Here, how many big squares does this portion consist of? It consists of one big square, right? In a one big square, how many small squares are there? Small squares, there are 10 of them. If you check the number of square in this length, there will be 10 squares. So same thing you have to write here in case of y-axis. In case of y-axis, you have to say here 10 small squares is equal to 1 unit. You can use is or is equal to, whatever your choice is. But the scale is different in the previous graph. Okay, in the previous graph, the scale is different. In order to write 1 unit, it take up two big squares, right? So one big square consists of 10 small square. The other big square also consists of 10 small square. Combine them together, there is 20 small square in order to make up this 1 unit. Same thing for y-axis also, x-axis and y-axis. So you have to write here as scale. As scale, you have to write here x-axis 10 small square is equal to 1 unit. Right for y-axis also. No, it's not 10. I'm sorry. It's 20. 20 small square is equal to 1 unit. Okay, one difference, if I if the value of y is very large, say you have to plot up to 20 or 30. If I plot like this, if I take so many space, if I take like this, there might be enough space available for you to plot up to 20. So I can just plot up to 4 here, there will be 5 here somewhere, 6 here, 7. Before I reach 20, my space will end, right? So you can change a little bit in x-axis. If x-axis remains the same, you can change y-axis. Y-axis, you can start here, 1, 2, 3. You can change the value. If x doesn't change and y change, if I plot here instead of here, then you have to change the value in the scale. In the scale, instead of 20 small square, you have to write 10 small square. Okay, scale is very important. You have to write the scale absolutely without fail when you draw the graph. Okay, let's take up one last question from solving two pair of equations using a graphical method. We have got 3x plus twice y is equal to 4, 6x plus 4y is equal to 13. Okay, look, let's take up the first equation, 3x plus twice y is equal to 4. Let's calculate the value of y. 2y is equal to 4 minus 3x. Y is 4 minus 3x divided by 2. Write the table here on the side. Let me write it with a different color. Table 1, x, y. We just need 2 points, right? So let's take the value of x as 0. Take x is equal to 0. Y is how much? 4 minus 3 into 0 divided by 2. So we have got 4 minus 0 by 2, which is 4 by 2. So we get 2 here. So when x is equal to 0, y is how much? 2. Take up another. Let's take up x is equal to 2. But now, what's the value of y? Y is 4 minus 3 into 2 divided by 2. So we got 4 minus 6 divided by 2, which is minus 2 by 2, which is minus 1. Okay, when x is 2, y is equal to minus 1. All right, what are the points? The points are here 0 and 2 combine, it's 0, 2. 2 and minus 1 combine, 2, minus 1. So just write here 0, 2 and 2, minus 1. Okay, let's plot them in the graph paper. Okay, this is the y-axis. Let's draw the x-axis here somewhere. Okay. Now you have to write the y prime, x prime, x, and the origin. So where are the points? This 0, 2, and 2 minus 1. You have to mark them first because the values are not very large. I'm going to take up 20 small squares. I'm going to take up here in order to mark 2 points. In order to mark 1 point here. 2 large squares in order to mark 1 point. So here is 1, Here is 2, 3, 4, 5. And do the same thing for the y-axis also. 0, 1, 2, 3, 4. So plot this 0, 2, and 2 minus 1. Remember, there is a negative value also. So negative minus 1, negative minus 2. 0, 2, where is it? There is 0. Go up. I think I plotted the wrong values. I put the wrong values. There is 1, 2, 3, 4, 5. So 0 here, go up 2 points. Here is 0, 2. So this point right here, this is what now? This is 0, comma. 2 comma minus 1, go 2 points on the x-axis. Minus 1 means you have to go 1 point downwards. 1 point downwards is up to here, right? So this is 2 comma minus 1. So it's 2 comma minus 1. Okay, now let's just join the 2 points in order to obtain our graph. No, okay, mistake again. Okay, let it be. So here is your graph. Here is your graph for the first equation here, 3x plus twice y is equal to 4. Here is the first graph. Okay, let's do away with the points, the equation for the first equation. Let's take up the second one. Let's take up 6x plus 4y is equal to 3. I'm rubbing this off everything else. Let's just put the table, okay. Table, you have to rub it off the points 0, 2, 2, minus 1. So table number, I'm writing it as 2. What's the next equation? Next equation is 6x plus 4y is equal to 13. So what do we get here? We get 6x plus 4y is equal to 13. Calculate the value of y. 4y is equal to 13 minus 6x. What about y? Y is 13 minus 6x divided by 4. Okay, let's start taking up values. Let's say I want, remember that we don't want any fractional value, okay? But in this case, whatever value of x that you are going to take, always you are going to get a fraction most of the time. So let's say, let me take up two values. Let's say I want to obtain, let's say I put x is equal to 2. Okay, so x is equal to 2. What is the value of y now? 12 minus 6 into 2 divided by, 13 minus 6 into 2 divided by 4. So we get 13 minus 6 into 2 is 12, right? So we get 1 by 4. 1 by 4, it will be no issue to plot at all. So when x is 2 and the value of x is 2, the value of y is 1 by 4. And let's say I want to take x is equal to minus 1. What now? We will get y is equal to 13 minus 6 into minus 1 divided by 4. Minus 6 and minus 1, if you multiply them, you're going to get positive 6, right? So 13 plus 6 divided by 4, this is 19 by 4. If you divide 19 and 4, you are going to get 4 4s are 16, 3 by 4, right? So if I put the value of x as minus 1, the value of y is how much? 4, 3 by 4. So since we take the value of x as negative 1, you have to have some negative values in the x-axis also, right? So I'm just extending the part, and then here is your, since we took two big squares in order to make one value, I'm writing here this is minus 1, this is minus 1, this point is minus 1. Okay, now let's plot them. 2 what are the points here? 2 and 1 by 4. So let's just write with writing. The points are 2 comma 1 by 4. What about the other? Minus 1 comma 4 whole 3 by 4. Okay, question is where will be 1 by 4? Okay, look, let me show you. Very easy. This is 1, right? If this is 1, okay, imagine here is 1. If I take only this portion, this will be half, isn't it? If this is 1, if this is 1, you divide it into 4 parts. How much here is half? You divided it into 2 parts now. Now we have got 4 parts, right? This one will represent 1 by 4. This one will represent half. This value will represent 3 by 4. Get it? So here is 1. If I divide 4 parts. If I take only 1, it's 1 by 4. If I take 2, it's half, because 2 by 4 is half. If I take 3, then we will get 3 by 4. Get it? So it's very easy to plot 1 by 4 if you plot it in a graph paper. So 2, 1 by 4, where will it be? In the x-axis, you go 2 points. And then 1 by 4 is where? 1 by 4 is here. Look, this is 1, right? So let me just draw it with rating for now. This is one value, isn't it? I'm cutting it into 4 parts. One here, one here, one here. So where will be 1 by 4? This portion is 1 by 4. So when I want 2 1 by 4, if I reach here, this will be 2 comma 1. I want 1 by 4 only, so this will be 2 1 by 4. This point right here, this will be 1 by 4. So here, this is a very small point. This is 2 comma 1 by 4. What about the other one? The other one is minus 1 comma 4 3 by 4, right? Where is minus 1? On the x-axis, you go negative 1. 4 3 by 4, that is a positive value, so you go up. How much? 4 and 3 quarters. Okay, there is 4 here. 3 quarters will be how much? If I reach here, this is 4. I need 3 quarters more. Okay, 3 quarters means this is one value. If I take up to here only, that is 1 by 4. If I reach here, this will be half. If I reach here, this will be 3 by 4. Okay, so 3 by 4 is this point right here. This is 3 by 4. So this point right here, this is 4 whole. No, sorry. Minus 1 comma 4 3 by 4. Okay, look at the 2 points. We have got this point and this point. Okay, it's very unfortunate that we get fractional values in case of this the second equation. So join here these 2 points. Look, if I join it roughly, what I am getting is the 2 lines, the 2 graphs, they're parallel, right? So let's just join them. Let me use yellow once more. Okay, so the 2 graphs are parallel. The red and yellow look very closely. They're parallel. What's the meaning of parallel? They are not going to intersect at any point if you make it longer in either side. Okay, if you make it longer this side or this side, they are not going to intersect. If the 2 graphs are parallel, that means there is no value of x and y which can satisfy these 2 equations right here. What do we call this condition as? We call it as inconsistent, right? What was the condition? A1 by A2 equal to B1 by B2 does not equal to C1 by C2. We have learned from the first video, right? So you can calculate here. We will obtain the same condition. A1 by A2 will be equal to B1 by B2, but it won't be equal to C1 by C2 as evidenced by the 2 parallel lines. So here, if you are asked to find the solution, since we are being asked to find the solution, we are going to say that since the 2 graphs are parallel, we have got 2 parallel graphs. That means there is no solution. So there is no value of x and y that can satisfy both equation. So we will say here, since the 2 graphs are parallel, there is no solution. Okay. So we have done 3 types of graph, 3 types of pair of equations, 3 pairs of equations, which yield a different form of graph. We have got consistent intersecting type of graph in the Roman number 8. In the Roman number 10, we have got same graph. That means the 2 lines, they are coincident. One is top of the other. And here for these 2 pair of equation, we have got 2 graphs, 2 lines which are parallel to each other. Parallel means we don't have solution. Okay. Take this Roman number 8, 10, and 12 as template. You solve the remaining. Okay, you practice more and more until you obtain the solution as given in your answer. So there are around 15, 16 questions, I believe, in question number 3 of your exercise 6.2. So sometimes sometimes this is a 3-mark question for your board examination. Okay, very important one. So keep practicing with this. Let's finish here for today. We will take up the remaining questions from your exercise on the next video. I will take up numerical problems, and then the methods that I have mentioned earlier. This is just a graphical method. We have mentioned substitution method, elimination method, and cross product method. I will teach you all of those one by one. So with this, let's stop here today. Let's stop here for today. I will see you all on the next video. Goodbye.